this video, we are talking about the signs of trigonometric functions. The signs of trigonometric ratios depend on the quadrant in which the terminal side lies. We always take the terminal side OP equals R as positive. So the signs of all the trigonometric functions really depend on the value of X and the value of Y in this triangle. So let's get started and explore the different possibilities and signs of all the trigonometric functions in different quadrants. In this triangle, sine theta will be defined as y over r, cos theta will be defined as x over r, and tan theta is defined as y over x. Starting with 0 degree, sine 0 degree is 0 over 1. The reason being, here in the triangle, the height of the triangle, which was given by y, is 0. So 0 over 1, that is equal to 0. If you move along, you will see that in the first quadrant, the value of sine is positive, and it is moving from 0 towards 1. Now moving on to cos 0 degree, here the value of x is 1 and the radius is also 1, or you can say the value of x coordinate is equal to the radius of the circle. So r over r is 1, or we can say 1 over 1 is 1. And as we move in anti-clockwise direction and increase the angle, you'll see that the value of cos of given angle is positive, and it is decreasing from 1 towards 0. Now for tan theta, starting with 0, tan 0 degrees, 0 over 1. Why? Because here y is 0, but x is 1. And if we move in anti-clockwise direction, you'll see that the value of tan theta is increasing as we are moving in the first quadrant, and it is positive. So let's recap. In first quadrant, we have sine, cos, and tan, all of them positive. And that means their reciprocals will also be positive. That being said, the reciprocal of sine, which is cosec, it will be positive. Reciprocal of cos, which is sec, that will be positive. And reciprocal of tan, which is cot, will also be positive. So far, we have found that in the first quadrant, sine theta, cos theta, tan theta, and their reciprocals are all positive. Now let's explore second quadrant. When we move into the second quadrant and observe the values of sine, cos, and tan, you will observe that the value of sine is positive, the value of cos is negative, and the value of tan is negative. And can you guess why? Yes, you are right. Because in the second quadrant, the value of y is positive, and we know that sine depends on the value of y. And the value of x is negative in the second quadrant, and cos depends on the value of x. How about tan? We know that tan is y over x. And here only one of them is negative. That means the fraction will be negative. And that is why tan is negative in the second quadrant. So in the second quadrant, we found that sine theta is positive. So its reciprocal will also be positive. And rest of the values, cos, tan, and the reciprocals will be negative. Let's move on to the third quadrant now. Moving into the third quadrant, we know that in third quadrant, both x and y are negative. And if we go into the third quadrant and change the angle, you'll see that the value of sine is negative and the value of cos is also negative. But the value of tan is positive. And can you tell me the reason why? Yes, you are right. Because a negative number divided by a negative number, so negative value of y divided by negative value of x will give you a positive answer. So that's why only tan is positive in the third quadrant, but sine and cos are negative. And it's quite obvious that reciprocal of tan will also be positive, and reciprocals of sine and cos will be negative. So we found that in the third quadrant, tan is positive, so its reciprocal is also positive, and rest of the trig ratios are negative. So sine is negative, cos is negative, and their reciprocals are negative. So let's move on to the fourth quadrant now. When we move into quadrant 4, we observe that the value of sine and tan is negative. And the only value which is positive is cos. Do you know why? The reason is that in the fourth quadrant, we have x value as positive and y value as negative. And cos depends on the value of x, and therefore it is positive. Sine depends on the value of y, it is negative. And tan is defined as the ratio of y over x. And as y is negative, but x is positive, so the answer that you will get will be negative. And that is why the value of tan is also negative. So in fourth quadrant, we have sine and tan negative, so their reciprocal will be negative. And the value of cos is positive, so its reciprocal will also be positive. So let's summarize this into the table now. So we found that in quadrant 4, you have cos as positive and its reciprocal will be positive, and rest of the values are negative. And this can be learned with an acronym after school to cinema. So after school to cinema, it's easy to remember. And here A stands for all, S stands for sine and its reciprocal, T stands for tan and its reciprocal, and C stands for cinema. Sorry, C stands for cos or its reciprocal. All right, now let's use what we have learned so far. So in this question, it is given that sine theta equals 12 over 13 and theta lies in the second quadrant. Find the value of sec theta plus tan theta. So the first thing that we'll do is write the acronym after school to cinema in anti-clockwise direction in all the quadrants. So we get that in second quadrant, you have sine and its reciprocal as positive, and all other trig ratios are negative. And we are given with the value of sine theta. So we are given with sine theta equals 12 over 13. So now let's find sec theta plus tan theta. Sec theta is 1 over cos theta, and tan theta is sine theta over cos theta. That means we have 1 plus sine theta over cos theta. This is what we want to find out. And we know that sine square theta plus cos square theta is equal to 1. That means cos square theta is same as 1 minus sine square theta, or cos theta is equal to plus or minus square root 1 minus sine square theta. Now, as in question, it is given that theta lies in second quadrant. That means the value of cos is negative. So we will take the negative sign and not the positive sign. So we'll have 1 plus sine theta value, which is 12 over 13, divided by negative square root of 1 minus sine square. And sine is 12 over 13, so 12 over 13 square. And if you simplify this, we get 25 over 13 divided by minus square root of 169 minus 144 over 169, or we can write minus 25 over 13 divided by square root of 25 over 169, which is same as 5 over 13. So 5 over 13, and you can cancel out 13, you can cancel out 5 and 25. So we will get the answer as minus 5. So the value of sec theta plus tan theta is minus 5. We know that in a unit circle, the value of sine theta can be given as y over r, cos theta as x over r, and tan theta as y over x. Now we will observe the variation in the values of all trigonometric functions in different quadrants. And here I'm not talking about the signs, but the variation in the values. Let's get started with sine. When we move through the first quadrant, we see that the value of sine is increasing from 0 to 1. And it is 1 when we are at 90 degrees. So we can say that sine theta in first quadrant moves from 0 to 1. And when we move in the second quadrant, you will observe that the value of sine is now decreasing. Do you know the reason why? Yes, you're right. Because sine depends on the value of y. And in the unit circle, the radius is 1. So it is y over 1. As the value of y is decreasing as we are moving towards 180 degrees, therefore the value of sine is also decreasing. And when we reach near to 180 degrees, the value of sine is nearly 0 because the value of y is nearly 0. And when we hit 180 degrees, the value of sine is 0. So we can say that in second quadrant, the value of sine changes from 1 to 0. And if we move further in quadrant 3, the value of y now becomes negative, because we know that in third quadrant, the y coordinate is negative. As the value of y is negative, that means the value of sine is decreasing. So now it is moving from 0 towards, yes, you're right, minus 1. So when we reach 270 degrees, the value of sine is minus 1. So in third quadrant, the value is changing from 0 to minus 1. As we move in the fourth quadrant, we'll observe that the value of sine is now increasing from minus 1 towards 0. So at 360 degrees, again, the value of sine will be 0. So the value of sine in the fourth quadrant changes from minus 1 towards 0. And don't worry about the table. I'll give you the summary at the end of the video. Now moving to cos, we know that cos is defined as x over r, and in a unit circle, the value of r is 1. So that means the value of cos depends on the value of x. So let's observe what happens to the value of cos when we move in the first, second, third, and fourth quadrant. So the value of cos theta, when we move from 0 degrees towards 90 degrees, it changes from 1 to 0. So we can write that in quadrant 1, it changes from 1 to 0. And when we move in second quadrant, the value of x is negative now, because in the second quadrant, we are moving towards the left side of the origin. That is negative value of x. That is why the value of cos is negative. Now it is decreasing from 0 towards -1. At 180 degrees, we'll find out that the value of cos theta is -1. So in second quadrant, the value of cos moves from 0 to -1. And moving in the third quadrant, again, the value of x is still negative. But when you move from 180 degrees towards 270 degrees, you'll find that the value of x is actually increasing from -1 towards 0. And that is why the value of cos is also increasing from -1 towards 0. So in the third quadrant, the value of cos is from -1 to 0. And if we move in the fourth quadrant, you'll see that now the value of x is positive, and therefore the value of cos will be positive, and as well as you are approaching towards 360 degrees, you'll find out that the value of cos is actually increasing from 0 towards 1. So in fourth quadrant, the value of cos changes from 0 to 1. For tan theta, we know that tan depends on the ratio y over x. So it depends on the value of y as well as the value of x. Let's see how the value of tan vary when we move from quadrant 1 towards quadrant 4. As you move from 0 degrees towards 90 degrees, the base of the triangle or the value of x is decreasing and it is approaching 0. As the denominator of a fraction approaches 0, the fraction approaches infinity, given that the numerator is not 0. So we can say that in the first quadrant, the value of tan approaches from 0 to a large number, or we can call it as infinity. Moving in the second quadrant, when you move from 90 degrees onwards, you'll see that the value of tan is a large negative number. That means from 90 degrees, if you move few points towards 180 degrees, the value of tan is largely negative, or we can call it as minus infinity. And when we reach 180 degrees, the value of y becomes 0, and the denominator, which is x, becomes -1. So you have 0 divided by -1, which is 0. So we can say that in the second quadrant, the value of tan varies from -infinity to 0. We know that in third quadrant, the value of y and x is negative. And that is why the value of tan, overall value of tan will be positive, but it is changing from 0 towards a large value as we move from 180 degrees to 270 degrees. So we can say that in third quadrant, the value of tan varies from 0 towards infinity. Last, when you move from 270 degrees towards 360 degrees, when you are just above 270 degrees, like 271, 272, you see that the value of y is largely negative and x is positive in this case in fourth quadrant. Therefore, the value of tan is largely negative. That means you are moving from minus infinity, and as you go closer to 360 degrees, you see that the value of tan is increasing and it is approaching 0. So we can say that in fourth quadrant, the value of tan varies from minus infinity to 0. So far, we have discussed how value of sine theta, cos theta, and tan theta changes when you move from first quadrant to fourth quadrant. Now let's see how the value of cot, cosec, and sec varies when we move from quadrant 1 towards quadrant 4. Starting with cot theta, which is equal to 1 over tan theta. We know that in first quadrant, tan varies from 0 to infinity. So cot will be something 1 over 0 to 1 over infinity. 1 over 0 is a very large number, or we can call it infinity. And 1 over infinity is a very small number, or we can say nearly 0. So that is why cot value will change from infinity to 0. So it will decrease from infinity to 0. And same reason can be given for quadrant 2, 3, and 4. And that will give you the values for all the quadrants. And we can use the same technique to find how the values of cosec and sec vary in quadrant 1, 2, 3, and 4. So in this video, we discussed the signs of all trigo functions in quadrant 1, 2, 3, and 4, and how their values vary in different quadrants. In the next video, we will discuss the domain, range, period, and graph of trigonometric functions. So I'll see you in the next one.